This video will demonstrate using some of the more advanced controls on SPARKVue and using with a sensor. Right now I have a smart cart connected to the sensor or to SPARKVue. And over here I want to point out a couple of things. First is this tells me what the force sensor is reading right now, and I am not applying any force to it, so it ought to read 0. And so if I click on this, I can zero the sensor now. I want to show you what that does. If I hit start, it would record every 20 times a second the force value, and it's not 0, and it should be, so I want to zero that out. So 0 sensor now shows it, and now I feel good about taking the measurements of force with this sensor, so I'll hit stop. Also over here it says periodic 20 hertz. HZ is hertz. That's the rate at which it's taking readings. 20 hertz is 20 times a second. So as 1 second goes by, there will be 20 data points here. That can be changed. It can be much less. It could be maybe just 10 times a second, 5 times a second, twice a second, or just 1 time a second. Every 1 second, it can collect a measurement, or we can go higher. Now, the higher we go, the bandwidth gets tested, and there may be a limit. With one sensor, we might get up to 500 hertz. If we have, say, 2 smart carts, which might be possible, sometimes we might have to go down to 250 or 200 hertz to work with the Chromebooks. So the default is 20, and for the purposes of this video, that's fine. So I will leave it at that. And next I'm going to get rid of this run here. So I'm going to go to manage runs and delete the last run. And that goes away. And I'm going to hit start again. And I'm getting a changing reading there. And I'm going to hit stop. So there's my data. And I want to show you how you can analyze the data using the tools here on this toolbar. Again, we can collapse the toolbar so we can see the axis clearly, or we can open up the toolbar to see what we can do. If I wanted to know the average force during those 9 seconds or so, I could click on the display window to grab the data. There it is, up to 8 seconds. And if I hit this Greek letter sigma, it's like a funny E, I can look for the minimum or maximum of those measurements, the mean values, standard deviation. I can count the number of values. I can get the area, which is helpful on some graphs. So let me just do the mean, the average. And it reports it's a negative 2.75. The negative just is a particular direction, in this case pushing into the smart cart. So if I look here, that looks like that's about in the middle, between 0 and -5. So that's good. If I wanted to, let's see, I'm done with this. I can X that window out. I can get rid of this mean value. And say this change right here interests me, and I want to know the slope of that line. I could grab that data right there, and then I can do a curve fit with this icon here, or this icon right down here. I'll hit it here. And it takes the data inside the window that's highlighted in yellow, and using y equals mx plus b form, it tells me m the slope and b the y-intercept. Now, it doesn't give me units, so I have to be smart enough to know that the y-intercept units are newtons, and the slope units would be newtons divided by seconds. And then down here are some statistics which we won't worry about right now, but R can be between +1 and -1, and the closer to 1 or -1 it is, the better fit the data is to a straight line. But what I'm trying to get the slope here, and I would look at this and know that the slope was a positive 0.81 newtons per second, and that might mean something to me. So that's a box here. We can also, if I get rid of this now, because I'm done with it, and click on this, I can also use this slope tool, and I can move it and get the slope at points along the curve. And you can see m is the slope, and here it's steep around 3.1, and here it's less steep at 0.47, and so forth. So That's what that tool is. This tool is helpful. It is a coordinate tool. It tells me the exact coordinates, and I can move that along point by point, and it shows me the seconds and the force in newtons at that particular data point. So that is a control here. Um, there is a text box we could put in if we wanted to write a note that something was of interest. And I can move that. And that could be a little way to add a note to a graph if you wanted to. It's possible to add axes. We typically don't do that here. You can make a mark. And when you're done, hit that, and you could leave a mark like that on. That might be helpful to you. Sometimes you want your data to be connected, sometimes you don't. So if we don't want to connect the data lines, I would hit off. And here you can see the data lines are not connected anymore. And often that is actually how I like to see the data. All right, so those are some of the more advanced features when you're working with data on a graph that is very helpful to know for analyzing the data that you collect and coming up with important measurements and understanding about what's happening.